All right, everyone, welcome back. We got 5.2 to simplify rational expressions. We are going to kind of just jump right into this. So we have two learning goals to simplify rational expressions. Very obvious. And then we have to state the domain restrictions. Okay, so even though we're not graphing in this one, we really need to pay attention to where these rational functions do not exist. Okay, now before we do that, we need to do a quick little review here, okay? What makes simplifying rational expressions difficult is that you have to factor over and over and over again, okay? And you have to know how to factor in so many different ways, okay? So if you're struggling with simplifying and you're trying to go, what weakness do I need to focus on? Factoring, okay? So here are three of the main ones, and I'm just going to jump right in and kind of do these really quickly. The first one is we can factor by the greatest common factor. We look at each term here, and we find the largest number that we could take out of both terms. And we kind of just start that off by looking at the numbers. I see a 3 and a 27, and I know immediately, well, it has to be the 3, right? Or it can't be a number bigger than the 3 because that's the smallest number, right? And then I check over to the 27. 3 goes into 27 9 times, so I can divide out that 3 to both terms, okay? Then I go to my variables. I see an x squared and an x. Obviously, we can't take two x's out of an x, but we could take an x out of two x's. So x makes it into our greatest common factor. And it's the same thing with y's. We have y to the power 2 and we have y. And so we can take out a y from both of these. So 3xy is our greatest common factor. And so we're going to write it on the outside and then actually divide it out. 3 divided by 3 is 1, so that just cancels. X squared divided by x is x. Remember, just a quick review, quotient of powers, you subtract the exponents, the same thing as saying that, 2 minus 1, okay? All right, and then the y's cancel because there's just a y over a y. So I'm left with x there, plus 27 divided by 3 is 9. X divided by x cancels, y to the power 2 divided by y gives me y. So this would be my new expression, okay? Factoring by greatest common factor is going to be huge, okay? Now, it looks like we have another factor by greatest common factor here. And this one's with the trinomial. And I felt it was important to do that because a lot of times we think that it only happens in two terms. And when we have three terms, we kind of skip into just trying to factor by maybe the diamond method. But you can still get to these situations where there is a single number that can be divided out. In this case, it's 4, because 4 goes into 4 and into 16. And I want to divide that out before I do anything else. Okay, the biggest reason for this is factoring when you have an a value that does not equal 1 is a pretty tough time, okay? But factoring when a is equal to 1 is super easy, and we can actually finish this, right? We have our diamond method. We have a times c up top, so a is now 1 because we got that 4 is on the outside. And c is 4, so our top number is just 4. Our bottom one is b, so that's 4. And we ask ourselves what times what multiplies 4, but also adds to be 4. And that's 2 and 2. So this can be broken down into 4 times x plus 2 times x plus 2. Okay, or really just 4 times x plus 2 squared. Same thing. Oh, and I guess this is all factored by greatest common factor, although this doesn't have a greatest common factor, so I made another error. This is going to be factored by difference of squares, which you are going to see. You remember, if you have a square, you have subtraction, and you have a square, then you can immediately jump to your factors, okay? We take the square root of x squared, which is just x, and we put it in the place of both the first ones. And then we take the square root of the second one, so square root of 16 is 4. We put it in place of both the second terms, but we make one plus and one a minus, okay? And I've talked a lot about this before, so I'm not going to go too in depth to it right now, but what this really means here is when you have the same terms, but one's a plus and one is a minus, the b term cancels out, and you're left with an a, and you're left with a c that are squares, and the subtraction of two of them, so we can immediately jump the other direction when we see this, okay? Now this does leave out factoring where a is not equal to 1. That's obviously one of the most difficult ones, and you are going to see that, okay? And I'm going to teach that one on the fly, okay? But remember, if you are struggling to simplify rational expressions, it's most likely because of factoring, because that's all we're really doing here is factoring and then simplifying it. Okay, so we're going to do some easy examples. These are all going to be divided into I do, you do's. Okay, and I'm going to try and do problems spread out among like very different types, so you're getting a good spectrum here. Okay, so the first one I'm going to do. So obviously this is we have a whole polynomial at the top, we have a whole polynomial on the bottom, and we want to kind of go through and simplify. And this one isn't too bad. It's just kind of like dividing, right? I see I have 3 over 27. Well, 27 can't go into 3, but looking at that as a fraction, we know that 3 goes into 3 and 3 goes into 27. So we can simplify that really to be 1 over 9, okay? And then I have y to the power of 7 over y to the power of 5. We use our quotient of powers, so that's y to the power of 2, okay? Now, we have to talk about our domain restrictions. Okay, that's our other thing here, is what are our domain restrictions? And when you look up your domain, or when you think about your domain restrictions, you don't look at the simplified one. You don't sit here and go, oh, let me look at what I have now. Because if you look at what you have now, you have no domain restrictions because there's no variables in the denominator's place. Right? Remember, domain restrictions things we cannot plug into these. And a lot of that time happens when there's a variable on the bottom because there's a number there that'll get you to a denominator of 0. And we can't have a denominator of 0. Okay? So when we do this, we don't look there. We look at our original, and we see that our original has a variable on the bottom. And it doesn't add with anything. It's just a variable that's multiplying. And so the only way we can multiply to get 0 is if y is 0, okay? And so our domain restriction here is that y cannot equal 0, okay? All right, now I'm gonna let you guys take a couple seconds. I want you to pause the video and give this next one a try. Okay, so this one is a little bit more difficult. Right? It's a little bit more difficult, but that's okay. We got 70. Well, first we had negative on the outside. That's fine. All right, let's put that in our answer. We have 70 over 28. Okay? You have to think about what number goes into both of them, right? I'm going to look at my smaller number, 28, and looking at this, I see we have a 70, so 7 times 10 is 70, and I want to kind of see does 7 go into 28, and it does, 4 times, okay? So I'm going to take 7 out of both of those. So 7 out of 70, which gives us just 10. And 7 out of 28, which gives us just 4, which you could probably see already that we can actually simplify even further, okay? Probably looking like, yep, 14 also goes into 70 and 28. So if you picked 14, you would have jumped to 5 over 2, but instead for us, we are going to go again. So 2 goes into 10 5 times, 2 goes into 4 2 times, okay? Now we look at our x's. We have x over x squared. That's fine. We are going to work that out. So if you think about this, this is x to the power 1 over x to the power 2. So that's x to the power 1 minus 2. So we get a negative 1 on the top, right? Which would normally look like this. However, when I see that negative, I immediately know it's supposed to jump to the bottom, right? Because we don't want to leave any negative exponents, and it's supposed to go into the denominator's place under 1. So we're going to put that immediately right there. And that's kind of why I did that in 2 stages, so that you could see. I look at this immediately, I say 1 minus 2 is negative 1, so that would be on the top, but I'm going to send it right to the bottom and make it positive. And then the next one is y to the power of 8 divided by y to the power of 5, so we can subtract those, right? And that would be y to the power of 3, okay? And then that's really just going to stay in our answer, okay? So now we need to think about domain restrictions. We're going to look at our original problem. There's 2 variables here, and so there's really 2 domain restrictions, right? It's that x cannot equal 0 and y cannot equal 0. These are your domain restrictions, okay? Because either of those could have an input, and neither of those can be 0. All right. Now, because if you're confused, well, how are these 0? You got to remember that this is a single term on the bottom. And it's all multiplication. And the only way a multiplication can get to 0 is if there is a 0 being multiplied, right? So that's how we know when there's just a variable with no adding and subtracting, and it's all multiplication, 0 is the domain restriction, okay? So I know that I had you kind of try one that was a little bit above the one that I did, and that's okay because I was going to do it right after we clean it up, okay? Okay, let's look at another one. These look very different from the other ones, right? So we see, I'm going to obviously same thing. I'll do the left one, you guys will do the right one. We have 27 on top divided by 27 times a plus 18. The 27 on top is completely simplified, so we don't have to worry about it. We do have to look at the bottom. And this is going to be that situation where you need to factor by greatest common factor. All right, so I look at 27, I look at 18, okay? I could see, I know that 3 goes into 27, and I know that 3 goes into 18, thinking about that, right? Now, if you're struggling with figuring this out, you can take your smallest number and just kind of write out all the factors of it. So I know 1 goes into 18, 2 goes into 18, 3 goes into 18, 4 doesn't, 5 doesn't, 6 does, 7 doesn't, 8 doesn't, 9 does, right? And in fact, looking at that, look at that, just caught one of my mistakes there, right? Well, and also 18 does. And we want to grab the highest number that goes into both, right? So I see that 9 can go into 27 and 9 can go into 18. Now, if you still don't see that, do the same thing with 27. Write out all the factors, 1, 3, and 9, and 27, and you could just find the highest one in each, okay? So let's erase that. We're not going to divide out by 3. We're going to divide out by 9, like this, okay? And so we're going to get 9 times 3a plus 2. And this was under 27, okay? Now, okay, let's look at this for a second here, all right? We are at its most simple stage. There's nothing else that we can do, okay? And I've told you a lot that when you do domain restrictions, that you should look at the original 2. And that's the case most of the time, okay? It really is the case most of the time. Most of the time, if you cancel something out, you have to look at the first one. Because even though something got canceled out, it was still in the original problem. And so there is still that domain restriction, okay? And that's kind of why I started off that way. But if you look at this one, nothing got canceled out. We just factored out a greatest common factor. So we do have a more simple one. Now here, it's a little bit less clear about, okay, what our domain restriction is. So what you kind of need to do is you need to ask yourself, you can treat this bottom like it's an equation and go, what makes it equal to 0? All right. And so I'm going to do that. I'm going to set that up and I'm going to solve. So I'm going to go 9 times 3a plus 2 is equal to 0. I'm going to solve for a. So I'm going to divide by 9, which cancels out. And that doesn't matter. 0 divided by 9 is just 0. So I have 3a plus 2 equals 0. I subtract 2. I get 3a equals negative 2. I subtract 3. And I get a is equal to negative 2 over 3. So that's that number that if I plug it in for a, I get a 0 in the denominator's place. And so a cannot equal negative 2 over 3. Like that. Okay? All right. So a little bit more complicated, right? In the second one, I want you to do the same thing. It's very similar type. Factor out that greatest common factor, and then tell me what the domain restriction is. So give it a pause and a try, obviously. Okay, so same thing here. At the bottom, the greatest common factor is a little bit easier to figure out. 10 goes into 10, 10 goes into 20. And so we're going to have 5 over 10 times k minus 2. Okay, and now this one actually, well, looking at this one, guess thought you were going to get me. So 27 over 9 could have been simplified a little bit further because 27 divided by 9 does give you just positive 3. And so we didn't have the most simple version over there. So let's go back here. We're going to have 3 over 3a plus 2. Okay, that's your most simple. All right. Now your domain restriction would still be the same thing because even though over here when we divided out that 9, it still became 0, so it didn't really matter. Okay, so good catch. All right. So I'm going to go back here, and we're going to actually fix that mistake here, 5 over 10. And we're going to get a 1 over 2 times k minus 2. Okay? Hold on, let me just take a look quickly. Okay, I did that one right. Okay. All right, so let's erase that so it doesn't look like a negative. Now that we're here, we're in our most simple form. All right, nothing got deleted. No variables got canceled out, right? We just ended up kind of rewriting things or simplifying ratios. All that's fine. So we could take the bottom, set it equal to 0, and find our domain restriction. So 2 times k minus 2 is equal to 0. Divide by 2, cancels. You get k minus 2 is equal to 0. Also, if you hear a lot of crying, my daughter is teething right now, and so FYI. Okay? I add 2 to both sides, and I get k is equal to 2, which means that's the exact number that this cannot be. So that's your domain restriction, is k cannot equal 2. And you can kind of start probably realizing that for some of these, you can just look at this and go, this is really what can't be equal to 0. And a 2 going there, 2 minus 2 gives you 0. It was harder to see on this other one, but if you can see them, you can kind of just make that jump. Okay? All right, now we're going to do a quick little math talk before going on and looking at some even more difficult ones. Okay? What I want to talk about next is what's called discontinuities versus asymptotes. All right? And when a certain thing leads to a certain, what gives you a discontinuity and what gives you an asymptote, right? These expressions here are going to be the type of rational expressions that we are about to do, okay? And they each lead to different things, okay? If you see that we have if I were to simplify this, let's not even look at the graph, okay? I have an x plus 2 over an x plus 2, well, that would cancel out, right? Because, it's the same thing over the same thing, right? So we would be able to divide that, and our new function would just be this, 1 over x minus 3. Well, remember what I was kind of trying to tell you guys already is that you can't just forget about these when you talk about your domain restrictions. So this one has a domain restriction where we say that x cannot equal negative 2, because if you put a negative 2 in place for x there, you would get 0. And it has a domain restriction of x cannot equal positive 3, because 3 minus 3 on the bottom would give you a 0. Okay? But if you look at the final simplified version here, it only shows the x minus 3. So which one leads to which? Okay, they're both going to be different. If you have that restriction left in the simplified version, like we do kind of here, where it's 1 over x minus 3, that is what gives you your asymptote. Hope I spelled that right. Okay? And this, in case, is your vertical asymptote, right? All right, and you can even see that that's at 3. So that's very clear, right? But then, if you kind of been seeing that this x is negative 2, there's just this open dot here, okay? And this is called a discontinuity. Okay, discontinuity, all right? And notice how it's not an asymptote. It's just all of a sudden we're like, we have solutions, we have solutions, we have solutions. We get to negative 2, we don't have anything here, and then we have solutions, we have solutions, okay? So it's just like this little, oh, we can't be right here, all right? But it doesn't, the function doesn't try to get close to it like it does with an asymptote and stuff like that, okay? So keep that in mind, all right? If you're wondering why we have to keep track of those earlier restrictions, this is why, okay? All right. Let's look at those more difficult ones now, all right? So this is the ultimate goal of what you're going to really be trying to get to, is an expression that looks like this. You're going to be given things more on this right, and you want to kind of break them down to factors and cancel out whatever factors you can. So if I look at this left one, this one's pretty much ready for us to go, right? I see a y plus 2 on top, a y minus 2 on top being multiplied, and I see a y minus 2 on bottom. So I see the same factor on top and bottom, so those cancel out. And my simplified rational expression is just y plus 2, okay? But when I get to my domain restrictions, I have to remember that I canceled out that y minus 2. So looking at the bottom, what would make that equal to 0? Well, this one's a little bit easier. We can kind of think of that number. 2 minus 2 is equal to 0. So y cannot equal 2. That's my domain restriction. Okay. Now, I do want you to do this one on the right. Okay. Just you have to do a little bit of factoring on the top, and then you should be able to get to the answer. Okay. So why don't you guys give that a try? Pause it, and I'll go over it in 5 seconds. Okay, so hopefully you gave that a try. All right, if you factored the top, you would have seen that 3 goes into both those terms. So you get 3 times n plus 5. Okay, and then that's over n plus 5. So we can see that we have the same terms on top, n plus 5 and n plus 5. Those cancel. And our simplified version is just 3. But when we do our domain restrictions, remember, you have to keep that, keep that original problem in mind sometimes. And we can see n plus 5 is equal to 0. If you solve it, you're going to get n cannot be negative 5. Okay. So hopefully you got that. If you didn't, that's okay. It's pretty new stuff. It takes some time to click. All right, and I think these are going to be the last two, and I got a little bit more math talk, right? Because we're starting to see rational expressions that are much more complicated than what we saw in 5.1, okay? And yeah, you're looking here, we have 3x squared minus 3, okay? And all that's, we got x minus 1 above. These are going to be more complicated, all right? Now, normally you would think, okay, we have two terms here. Maybe it's a difference of squares, but 3 is not a square, okay? But I do see a greatest common factor. So I'm going to have to divide that out in the bottom. And so I still have x minus 1 up top over 3 times x squared minus 1. And now x squared minus 1 is a difference of squares, okay? Because you have a square on the left, you have a square on the right, you got subtraction in the middle. So this becomes x minus 1 over 3 times x plus 1 times x minus 1. We got that from difference of squares. Now let me pause here. This is where students get confused on this. Just think about this. First, we factored by GCF, greatest common factor. And then after we did that, and only after we did that, it was revealed to us that there was a difference of squares. Okay? And now if you look at our simplified problem, well, it looks less simplified, but if you look at it, all of a sudden, check this out. Look, we have an x minus 1 and an x minus 1 on top and bottom that could be canceled out. No one said to factor by greatest common factor, right? You have to remember all the factoring methods, okay? And you have to look at the problem and know when to use them. And that's what makes this lesson tough, okay? Because if you don't try different combinations or know about them all, it can be very difficult. Okay, now over here, we're going to have 1 over 3 times x plus 1. All right, now we're going to list our domain restrictions. Which is x cannot equal negative 1, right? And that's this one right here, because a negative 1 plus 1 will give you 0, right? And that one really is your asymptote. And then we also have, looking back at the one we canceled out, the x minus 1 over x minus 1, we have x cannot equal positive 1. Okay? So 2 domain restrictions. Definitely one of the most common errors. Okay? Now, on the right here, I am going to have you guys try this one. I know this one is much more difficult. Okay? And you can't get rid of that a is equal to, well, you can kind of manipulate a little bit, but you are going to have an a value that's not 1 for this problem. Which, if you remember that longer method of factoring, it'll be easy. If not, then I'll show you how to do it. So pause it, give it a try though. Okay, so the bottom is a little bit easier. We have x squared minus 4. That's a difference of squares, right? You have a square on the left, square on the right. And so you're going to get x plus 2 times x minus 2 on the bottom, okay? That's that difference of squares. Allows us to really, really, really quickly figure it out, okay? Now the top, 4x squared plus 6x minus 4. I'm going to kind of carve out some space over here to factor that out, okay? Now, if you try to take out the greatest common factor first, okay, you could do that. The greatest common factor, though, is 2. So if you divide by 2, all the way through, you only get 2 times 2x squared plus 3x minus 2. You didn't get rid of it, right? You didn't get rid of the a value, but you do have smaller numbers. So that can't hurt. That's probably helpful. So once we do here, we got our quadratic in here, right? We're going to have to factor this using that diamond method and then factor by grouping. So a times c, so 2 times negative 2 is negative 4 up top, 3 on the bottom, right? We got to ask ourselves what times what gives us negative 4 that adds to be 3, which would be 4 and negative 1, because 4 minus 1 is 3. 4 times negative 1 is negative 4. And then we have to rewrite our expression by splitting that middle term, this 3x, with these two terms, okay? So we're going to get 2 times 2x squared plus 4x minus 1x minus 2. Now, if you're confused, remember, this 3x split using those numbers, okay? Now, this is old school. We did this, I think, in Unit 3, okay? It's one of the more difficult types, all right? And then we have to factor by grouping. So we group the first two, we group the second two, and we factor out the greatest common factor of each, okay? So we still have this 2 on the outside. I'm going to forget about it for a second, though, okay? So 2x squared plus 4x, the greatest common factor there is 2x. So I factor that out, and I'm going to get x plus 2. Awesome. Negative 1x and minus 2. I'm going to take out the negative 1 so that I can get this to a positive binomial like the other one. And so I have a minus 1 times x plus 2. Okay, awesome. Now once I do that, I have those same binomials, so I could bring them together. So I get 2x minus 1 times x plus 2. And I do have this 2 on the outside that I'm going to bring back now, because now that's in its kind of most simple form. So it's not going to kind of look like it's next to another factor, okay? So I'm going to bring all this back over here, all right? This is 2 times 2x minus 1 times x plus 2, okay? And now we can start to see that there's a similar factor on top and bottom. There's the x plus 2. We can cancel it out, okay? So we're left with our most simple form of 2 times 2x minus 1 divided by x minus 2, okay? So that's our answer. But then we look at our domain restrictions, and I'm going to look kind of back to before we canceled out. I have an x plus 2 and an x minus 2. So I'm pretty much have both of the 2's, right? It can't be negative 2, and it can't be positive 2. So that one was pretty difficult, right? If you've forgotten how to do this, okay, I'm going to tell you right now, there will be a quiz question where you have to do that. Okay, so you're going to need to go back and watch that video and re-practice that if you've forgotten how to do it, because you will have problems with this, all right? You will not have every problem like that, but you will have stuff like that, okay? All right, now I got our last thing here, so a little bit of a math talk, okay? And I think it's important that we go over this. And the biggest reason why is, you're starting to see rational functions that we didn't graph. Ours were very simple, like a 2 over x minus 3 and then a plus 7 on the outside. And you got to be wondering, like, well, what the heck are these? These things are way more complicated. And if you look here, this graph on the right that has another location here, and I know it's hard to see, but this is a asymptote and this is an asymptote. So it has 2 asymptotes and it's got a graph in 3 different places. That came from this, okay? Now, in our standards here, at our school, this is done in pre-calculus. The graphing of these ones is done in pre-calculus, okay? But all the steps I'm showing you right now in 5.2 of simplifying rational expressions needs to be done to this problem in order to even get this graph, okay? So if you hang in with, in this unit, pre-calculus is going to be, or this unit in pre-calculus will be much easier, okay? And sometimes in math, that's kind of what it is. Sometimes it's like I'm learning this to be successful in a future date for a concept that is really used in cutting edge, okay? So that's really all I got here, everyone. Thanks for hanging in with me there, and I will see you guys next time. Enjoy.